The problem. Testing asynchronous code and static methods/objects can be a major headache. When dealing with coroutines, traditional testing approaches often fail due to the non-blocking nature of asynchronous operations. Similarly, static methods and singleton objects introduce tight coupling, making it difficult to isolate and test individual components. This often leads to brittle tests that are hard to maintain and don't accurately reflect the behavior of your code. The real-world scenario. Imagine you're building a data processing pipeline. Your data repository fetches raw data from a remote data source using a suspending function, Coroutines, and then transforms it. You also have a secret service that accesses an API key from a singleton global config and masks it using an extension function before processing. Now, how do you test these components without actually hitting the network, or exposing your real API key? The solution. Let's break down the code and see how MockK comes to the rescue. Example 1, Coroutines and suspending functions. Here's what's happening. 1. We define a remote data source interface with a suspending function fetch data. 2. The data repository uses this interface to fetch data and process it, simulating network delay with delay. 3. In the test, we use MockK remote data source to create a MockK implementation of the data source. 4. Every dataSource.fetchData ID returns Kotlin art sets up a coroutine expectation when fetch data is called with 123 return Kotlin art. 5. Runtest ensures that the test waits for the coroutine to complete. 6. Verify confirms that fetch data was called exactly once. Example 2, mocking object and extension functions. Key points. 1. Mock object, global config, mocks the singleton object global config. 2. Every global config.getAPI key returns mocked key defines the mock behavior for the getAPI key function. 3. Mock static, com.easymind.testing.junit5.chapter4.chapter4_code kt, mocks the Kotlin file containing the extension function.